So this is what we will be building. It is a game that was based on the Wobbler. It was a game for a game jam that someone developed, and that inspired several people to implement it on an Arduino, because the original person that made it for the game jam didn't have any plans of commercializing that game. At least that's what I read. And that uses basically just a string of LEDs and implements characters on that string, and you can move around. And the game itself uses a accelerometer on a spring, so that's why it is called TWANG. And you can move it around to move the character around. So I will just briefly disable the music. Let's do that. And let's play this video and watch how the game looks like.
And it starts up. So the goal is to move the green dot to the blue dot. Each level will progress and add increasingly difficult things. The way this works is there is an accelerometer mounted on the top of a door spring. So it gives very good proportional movement, slow and fast. To show that it's just a accelerometer, you can actually just tip the unit and it works the same way. The other feature with the accelerometer is the twang attack. When you whack it or give it a quick movement, it creates like an attack zone. So the first level, you just go to the end, showing you that you need to go from the start to the blue LED. Then it starts sending enemies your way. This is just going to send one enemy, and I can kill it like that.
All right, so that should essentially describe how the game works. There are other also other obstacles that are on the string. There are like conveyor belts, there are lava pits, and when the thing is in idle, it goes into a screensaver mode. And I saw this build at the Congress. Someone put it on a pretty tall pole in the not far away from our table where we were. Unfortunately, I didn't make a photo of it, but you can imagine it from that video, how that looked like. And I thought for a while now that I would like to build something for the Tour Camp 2020. So this is a camp that happens every 2 years in the gaps between the Dutch camp and the Chaos camp. And it is happening at the Orcas Islands, or San Juan Islands in Washington. And it is an outdoor event, and I thought it would be really cool to put up a string of LEDs, a really long one on a really tall pole, and set up this as a game that is basically visible from all around the camp. So that's the basic idea. And I could just take an Arduino and slap it together, but that would not be yak-shavy enough, I think. So I would like to use the opportunity of building this game for the event as an opportunity to do some stuff with the icebreaker. So for the icebreaker, I would like to port the game at the end completely onto the icebreaker. Instead of an Arduino, use a RISC-V or even maybe an AVR, which is also possible to put on an FPGA, and run the game on there, and then use direct hardware devices then yeah, to have the drive or the protocol implementation in hardware. I think that would be a fairly interesting project. Also, it would give some examples for people that want to use the Icebreaker as a Arduino replacement with dedicated hardware. There are two paths we can take on this. One is with MicroPython or CircuitPython. The other one is with just Arduino. And there's the third one, of course, to just use C or even Rust. So there's multiple ways of implementing it. And the question is which one makes most sense. The path I started taking is actually the Python path, because I think CircuitPython or MicroPython is becoming quite popular these days, and people would enjoy to have MicroPython on the Icebreaker, and the whole project would help getting these things fleshed out and working. Sajatak, yeah, that's the name. Welcome to the stream. And yeah, it is. You have to buy the tickets in advance. It was still available about 2 months ago in December, and I know that there's always someone on the mailing list who says that they have spare tickets. So if you are interested in going to TourCamp, you should definitely try to find the mailing list and keep an eye out, because someone might have a spare ticket for TourCamp. So not all is lost if you really want to go there. Yeah, just send me a message on Discord and I can direct you in the right direction. So we can, usually it is possible to still get a ticket if you want one. So, so the path I took is with Python. So the first thing I wanted to do is also for development reasons to have the software ported to just desktop Python and simulate the LED string. So also to explain a few things about what you're seeing on my desktop here. Besides the keyboard IO keyboard, which is for typing, this is an LED string that I got. It is APA 102. I know there are also SK clones of these, which are a little bit more affordable. I might be using those because I need at least 5 meters of this. This is just 1 meter. And I still would like to use the dense ones, even though on a long pole that is in the sky, like higher up, it shouldn't be a problem if we use coarser pitch LEDs. But yeah, I still not convinced which physical manifestation it will take, if it will be coarser LEDs or finer LEDs. I definitely want to use the APA 102s because as one of the screensavers, I would like to have the persistence of vision, where you draw a picture and when you move your eyes, you see the picture. If you just look at the string, it looks static. So that's a neat thing to have. So I want to have that possibility if I come around to implementing that. So that's one. Then two, I don't have an accelerometer board at the moment. I could get one, but I thought it would be pretty cool still to implement that, the controls with an actual arcade joystick, which has nice and clicky buttons. Essentially you would go up and down, and this will set a tilt of 90 degrees, plus and minus, when you go up and down, and you would have to basically be very fast in controlling it. We should just try it out if this works out, to control the game at all this way. Also, considering that I'm making changes, probably we will end up implementing things differently and letting the game evolve if I'm doing all the porting to Python anyways. So having simulation means that you don't really need the hardware. You can use your keyboard on your computer and display the string on the monitor. So I am hoping that this way we can have more additional people working on the gameplay and also developing the game. And this especially will be useful at the event, where hopefully this will allow some people to contribute new things, and I can update the game while we are at Tour Camp. So yeah, that's the mechanics here. The option of the accelerometer is still out there. We can still do that, but I was currently not planning on it. I was planning to start with this. And even before we build the hardware, I was planning to write everything in software and do the porting to Python, so that the Python ported code can then be moved onto MicroPython. So this is a bunch of different layers to this, so it is much more a longer stack of different layers of the software than your usual computer game. So it should be interesting. Yeah. So what else? Let's see. There we go. Yeah, so I already started on the Python implementation. There's two implement. So I am basing it on a Arduino implementation, and basically started just porting it one-to-one to Python. So the code here that I am basing it on. Let's go. Yeah, we can switch on the music again. There we go. So TWANG. So this is the code base. You can find, I did some cleanups here. So the original code base in Arduino was implemented in an, let's say, interesting way. There is still a bunch of spaghetti code in here. So if I end up actually porting the Arduino code itself onto a RISC-V, onto the Icebreaker, which is also an option, I will clean up this code base even more and reorganize the classes, because all the stepped updates of each of the objects is actually being done in the main loop, which is a little bit weird, instead of doing it in the objects. But either I misunderstand some architectural decision here, or it was just how it evolved. Probably just how it evolved. That's much more likely. This is my code. It's currently just one Python file, so I only ported the screensavers so far. So let's see if we can run the current code base. Do I have it open somewhere? Yes. PyCharm. So yeah, there you go. On the top you see the string of the LEDs. I should probably hide this. Yeah, so there's the end of the string. There's not much hidden behind the display there. But yeah, that's how it looks like at the moment. I am thinking of continuing porting the code base. I might do some of that on stream, some of that off stream, but yeah, I'm using that also as an opportunity for myself. I never really built a project using Python before, so this will be quite a learning curve for myself. I just, the other day, for the first time, like for Christmas, I got myself a proper course for Python. So I finally tried to formally learn Python, and I learned a lot. It was very, very useful. It was really worth it. It was an Udemy from zero to hero or something course. It was very good. I can really recommend that to you if you are planning to learn Python a little bit in a more structured way. Yeah, before that, it was basically me modifying some scripts of someone else, and that ended up being yeah, it works, but I didn't have I was confused by certain constructs in Python still, and I wanted to improve that situation there. Yeah, so let's see. I wanted to, besides explaining the project itself, I thought I would do some planning about what the things are that we should implement first, and what the options are, and what the current plan is for the project as is. Let's see. So yeah, we have a text editor here. So yeah, what do we have currently? We have several paths we can take, so let's think about that. Let's do about goal first. So that's given. So that's also said that we will be using the Icebreaker as computing platform, and then we want to use implement POV effects. So for those that might not know, the reason why the APA 102s are better for POV effects than, for example, WS2812s is that the PWM frequency internal to the LEDs is much higher in the APA 102s. So I think it is 3 kilohertz or something along those lines, which is, there is a term for that. I just found it the other day. It basically is beyond the flicker factor, which means your eye is not able to distinguish the flickers even if it is moving. So it is beyond the hysteresis of our eye. So if you watch video on a screen like 24 frames per second, this is below the threshold. It still makes it smooth because it's not, the screen itself is not moving. But if you moved the TV or the monitor, then you would see smearing and dots actually being created. So you have to go beyond like 120 hertz to, I think that's the threshold. And this is with 3 kilohertz, it is way beyond that. So you can make persistence of vision effects by taking these LEDs and drawing a picture and then moving it the string fast, and then it will leave a trail that will create the picture for you. So that's the idea with why I want APA 102s. Also, they are more consistent, and also they will give less of a headache to people, hopefully, because they will not be flickery in the corner of UI. So if people see that in the field, they will be not annoyed by this thing being out there. That's my hope. Okay, what next? Arcade. It has to be waterproof, but this is for mechanical requirements. So because it's outdoors, it has to be waterproof. But this is not that important for here. Yeah. Yeah, that's the important thing. Have a simulated version available so people can develop for the platform without having the necessary hardware. Yeah, so that would be the goal. Let's see. So so possible implementations. So the possible implementations are port the Arduino code to the RISC. Yeah, so someone actually posted this. So let's look at that. So for the Arduino implementation, we could do the following. Icebreaker. I'm trying to figure out where that was. Issues? I think this was in here. Yeah, there we go. So someone posted this on the Icebreaker repository, which is very interesting. There are already ports for AVR. There's an AVR core for the ICE40. There's Arduino, which is also an IP core. So I think that, yeah, I didn't read in very detail what it is, but so there are several FPGA-related projects to get the Arduino code itself running on the Icebreaker. I would definitely prefer if it was a Pico RV32, for example, or other RISC-V instead of an AVR core implementation. So, but this is a viable path to essentially use the opportunity of this project to help get that implemented. So that's an option. LAT, is that the name? LATT Uino. The problem here is that I'm not a huge fan of Arduino in general, so I'm not sure I am the. But it's doable. I can do it. It's yeah. The Arduino stuff will not provide. It will be useful for the platform for Icebreaker, but it will be a little bit less of a useful thing for me personally to learn something while doing that. So doing the Python porting will give me the opportunity to improve my Python skills. So yeah, it's possible, but I'm not sure this is the right path to take. Port the Arduino code to Python. And that would be TWANG. So in the first case, we and then Arduino to Python, and then to a LaTeX, for example, a LaTeX-based MicroPython. So MicroPython is already a viable target platform for the tiny, no, not tiny FPGA, for FOMU from Mithro, Tim Ansel. So and Sean Cross, so Zobs. Yeah, so that would be a possible way. Just checking, is the chat just very quiet, or is something broken again in Twitch? I hope it is just very quiet over there. Oh, okay, good. So that's thank you. It's just quiet over there. Okay, cool. So if we take the Python path, then the first step would be to finish porting the current code base to Python. Then do some polishing. I was thinking a nice thing would be to, as a next step, allow not only output to the display, but also make the icebreaker a driver for the LEDs, and drive the basically take the PC, have a streamer that sends the pixels to the icebreaker, and then the icebreaker drives the LED string. Because what you see here currently on the table, this is driven by what is it called? Now my brain is blanking. From Electromage, brain is blanking. Pixel. This is a WS2812 Wi-Fi device. It has it generates all the patterns directly on the LEDs. It's a very very nice nice board actually. So let me show you really quick what I'm currently using. It is the Pixel Blaze. There we go. So Pixel Blaze is the current thing that I have attached to it to get it working. That was seriously like 15 minutes of just plugging in the cables. I had to solder in the header. This thing is amazing. It is so easy to set up, and it has a Wi-Fi server. So you just connect to it with to the gateway, and you can configure it. You can even program it from the Discovery service. Maybe it is even there. Yeah, I have it here, so I can connect to it. So yeah, this is this string that is currently running. So if you look at it, I can just select any pattern I want. So I can do block reflection. So now it has changed the design. It's so cool. And yeah, for those that hate JavaScript, this is JavaScript, and this makes it pretty neat and easy to set up. So use the right tools for the right problem, I guess. Oh, this is the sound-based stuff, so I can't use it. I don't have this. You can have hats onto this that have sensors, like tilt sensor and sound sensors and light sensors. It's pretty cool. So if you want to just have a nice effect thing that reacts to the music in your room, for example, this is pretty much a perfect solution. So I can really recommend this. So I met Ben at SuperCon. The last 2 years I went there. So at some point we traded an icebreaker for the Pixel Blaze. And it only took me 2 years to finally play with his pixel bass. So, but I did. And it's awesome. I can definitely recommend that to you guys. Okay, all right. So another distraction here. Yeah, we could theoretically implement TWANG directly on the ESP32 on the pixel base. That would be also an option. But where's the fun in that? Let's do some FPGA stuff here. So. Yeah, so Sajatak is asking, what is that Hacknet music? No, this is actually Spotify. So this is, if you look in the description of the stream, there's a link to a playlist. So this playlist that you're hearing now is not exactly that one, but I filtered out some of the songs out of the new retrowave latest music playlist, and I mostly removed vocal tracks because that's distracting for the stream, I feel, and I'm keep filtering it, so I keep listening to it. There's a lot of songs in there, but I try to like listen to it while I'm coding, and then when I run into a track where it's like, oh, this won't be good for stream, I remove it, and it's just an ongoing process of me filtering it out. But I can send you the link to my current playlist. Let's see where that is. Share, copy playlist link. There we go. There we go. So that's the current playlist here. I should update the description on the stream, so I will do that later. Okie dokie. So let's go back. So that port current TWANG implementation to Python. So then that's step one. Then add gateway IP, or develop for the icebreaker and to drive from the PC through the icebreaker. Also, this IP would then include joystick inputs. Either joystick as well as spring. So accelerometer spring would be the actual TWANG controller. Or yeah, let's as well as TWANG controller. The annoying thing about doing the accelerometer path is that I would have to use some I2C core, and I hate I2C because it's unreliable and very susceptible to EMI and stuff like that. So I don't like it. There's SPI interface I could use for that, so that would be less painful. But it requires initialization, and doing any state machines for initializations is annoying. And a joystick that has just buttons is so much easier. I just have switches on it. What would be another possible alternative, which would be interesting, is to actually build a joystick that uses a potentiometer for back and forth and uses switches side to side. And so to have the TWANG attack be side-to-side switches and back to front. But then we are really getting into a deep rabbit hole of developing our own controller. So at least the TWANG controller, I can try to, I don't have a 3D printer, but I hopefully can either ask someone or find a 3D printer somewhere and build the TWANG controller 3D printed case with the spring and the accelerometer on top. So there is a little bit less of development time involved there. What I'm concerned about a little bit is weatherproofing the TWANG controller. I think the arcade joystick will be a bit easier to weatherproof in like a nice waterproof box. So yeah, I don't know. Yeah. Oh, I'm getting pop-ups on here. Anyways, sorry about that. I should disable those. Yeah, so that's this step 2. And then step 3 would be basically get MicroPython working on the icebreaker. I think it pretty much works, but I'm not sure. I didn't test it myself, so that would be an interesting project to do. Test MicroPython on and then add the LED strip drive or frame buffer and drive IP to the MicroPython or the RISC-V core, RISC-V SoC, let's say. Add joystick IP to the RISC-V SoC, and then they probably are they're just memory mapped, so it should be fairly easy to just directly control it from MicroPython, and then add the necessary IP to MicroPython, the necessary API to MicroPython. IO, basically. So yeah, that's a bunch of these steps. So I think that should be doable. The alternative, if we go just Arduino path, this is definitely simpler because we can completely forgo the TWANG port. The first step would be this might be on the icebreaker side of things, a little bit more development, I have the feeling, because Sean and Tim put a lot of effort into the MicroPython and LiteX support on that end. So because they got it all working on the FOMU, they already put a lot of effort on that end for the MicroPython support. So it should be easier to port the FOMU MicroPython setup to the icebreaker than porting the Arduino stuff, especially the AVR core. I don't know. I will only see how hard all these things are when I try actually to get them to work. So we will have to see if we decide to go that path. I should probably on Twitter do a straw poll, what is more interesting to people. Is the MicroPython support on the icebreaker more interesting, or Arduino support on the icebreaker is more useful to people? So yeah, I don't know. So get Arduino working, and then port and keep cleaning up the TWANG code for the icebreaker. And yeah, and then build the hardware. Yeah, we should add that here too. So optional things. So let's do that this way. Possible implementations, goal, blah, blah, blah. Okay, optional. So optional, the thing that I was mentioning is the POV screensaver. But also, what was I thinking? There was one other optional thing to do. There was something else. Like, let's find this. Okay. POV screensaver. Oh, right. The games also have audio, which I completely ignored. And the game does have this audio when you are moving up and down. I'm not sure I really want this in the field or very loud. It might be very quiet near the player, because blasting the whole camp with scratchy game audio, I think that's pretty rude. So, but still, yeah, we should just put it in the optional part. It's like add audio support. Right, now I remember what is the optional thing. So the interesting thing is, so enable sanctions. yeah, that's a good one. Yeah, we should. How is that spelled? Is that correct? Okay, I will add it there. It's fine. Thank you. There we go. Then what is yeah, right. So the interesting thing was when I was asking in Discord about this project and about MicroPython on the icebreaker, TNT pointed out that yeah, I might run out of resources on the device and whatnot. So I was thinking that a lot of the effects rely on very specific animation characteristics. Like, for example, a lot of the screensavers, with each frame, they fade the LEDs by a certain percentage. So basically, they draw only one. They fade all the LEDs by 50% and then draw a new pixel on top of that. So basically, you create this trails behind an LED by creating, by fading each frame all the LEDs. So what we could do is actually implement those parts in hardware and have a little bit something like a pixel, like a PPU or a pixel processing unit on a Game Boy or an NES, which has built-in hardware capabilities, where we say, please, for the whole frame buffer, which is just the string of the LEDs on the FPGA, with every update that I send you, before you write that, fade all the LEDs by 50%, or something along those lines, where we have every frame that is also implemented in the hardware, please do a certain step to each LED, or have pair LED special interrupts where you can process a few instructions, so you can rotate through the HSV spectrum or something like that. Or yeah, so implement certain things that we would implement in software and move them on the hardware layer inside the FPGA. So that would be an interesting thing to do. But it is currently optional because the main goal is to get the game implemented. But when we have it done, we can start adding those cool features. So move software to hardware. Yeah, another term would be shader, right? So that would be fun. Yeah. So that is essentially the plan for now. I think I should post that somewhere in the project. I think I will just create a gist for this and then post it in the future. Then other to-dos. I should do a straw poll. Yeah. So yeah, I don't know. Maybe should we do it on Twitter? I'm not sure which way I should do that, but I will decide that probably after the stream, and post it. I will post it in the Discord channel, whichever I decide in the streaming channel on Discord. One way or another, we will do that. All right, thank you. All right, so now how far are we time-wise today? Oh yeah, so we have plenty of time. Yeah, as I said before, I want to keep the streams to around 2 hours. So we have a little bit of a plan, and let me just show you a little bit of the code base as it is currently, and show you around how the game is currently implemented in Arduino. And then we might be doing some refactoring on the Python code just for the fun of it, and see basically so that we all can learn about what this current status of the game is and how it is implemented, because I find those things usually very interesting. So that's another factor in this whole thing. I am not building a new game. I am porting someone else's game. I am not really a game developer, and I found that game interesting, and it is an interesting project, and see it as my yeah. I'm just a fan of this, and I think it might be a fun project to learn about a little bit about game development from someone who did that. Yeah, so this is the current code base. So as you see, there's already a bunch of people that worked on this, and I'm not sure if this is the newest version after my cleanups. I think it might be. Let's see. I did the wrong thing here. correct. Let me go here. Yeah, so this is TWANG. Oh god. There we go. Yeah, this is the cleanup one. Yeah, there we go. So the major structure of the game is you have the Arduino sketch on the top of this, the whole structure. Then in there we have the several objects that are implemented. There's a spawner that spawns enemies. There's lava, which is an obstacle. We have joystick to generate the joystick commands. We have an enemy, which is an object. We have a boss as an object. We have a conveyor belt, which will be either pushing you downwards or upwards. And there's a sinus implementation, which is pretty irrelevant. So the structure of the game is very, very simple. So it should be very easy for a casual passerby to also understand what the structure is. Then we have the main loop. So in startup, it just sets up the fast LED library, which is used to drive the LEDs. Then we have, this is an interesting thing. If we were porting the Arduino code to the Icebreaker, what do we do with FastLED? I think we have to port FastLED and change the way it is driving the LEDs, because we just will have a frame buffer for the LEDs and the FPGA will be shifting them out. Siege Attack, thank you for coming and thank you for joining in the stream. Have a good one. Yeah, so this is something we will have to think about and probably port. That will be interesting, because currently FastLED is it has a bunch of additional functionality for managing LEDs, which you will see later when we are trying to port anything. It implements conversion from hue saturation, what is it, HSV? Hue saturation and, oh god, I don't remember, but it's into the RGB space and vice versa. Yeah, yes, most of the Arduino, so Ed is saying that if the SoC is an AVR, the Arduino LEDs libs will work almost out of the box. That is true. Although, yeah, I could basically just have an AVR with the same interfaces as the Arduino, but I have the feeling this will be fairly slow, because although it is just 8 megahertz, right, or 16 megahertz. So I guess you're right. We could run on the Icebreaker an AVR at 16 megahertz. That doesn't sound too terrible. Yeah, if the I/O is exactly the same, then all of this will just pretty much work out of the box. So that's a good point. If I want to do it the quote-unquote cool way, then I would change the peripheral that is connected to the core to do LED driving correctly. So not bit bang it, but yeah, exactly. It won't be very much fun to just put an Arduino on the Icebreaker, but it would be a good start, I guess. And it's to get to blinky LEDs and something working. Yeah. Yeah. Yeah, that's exactly the feeling I'm getting. It's not super. We will not learn very much doing this. or not as much. We will still definitely learn something doing this, but I think we will not learn as much if we go down that path. Okay, so let me go back to the code, and then we have a pretty large main loop that goes on for a while. So let's break it down. So we have, it is using mainly the millis function, so milliseconds counter, to drive most of the effects and most of the gameplay. And I was mostly interested in, so first thing that it does, it is checking if serial is available, and then loops over and over again through here. So to control the frame rate, it is taking the min redraw interval, which is set up here somewhere. I think it's 60 FPS. Where was that? Did I move it already? I was reorganizing the code base a bit. Anyway, so I think it is 60 FPS. So if there is no data to be processed from the serial port for the console for configuration of the device, so you can configure the game through the serial port. Essentially set up how long the LED string is, if you want the audio on or off, how long it should take until the screensaver kicks in. I think you can choose which controller it is actually using. Is it using buttons or is it using an accelerometer? And then a few others. So nothing too exciting. It's just for configuration to make it easy to set up the game wherever you are with whatever display you have. Then in the main loop, you have it is getting the input from the joystick. It's checking if the tilt of the joystick is outside of the dead zone, and checks if it should exit the screensaver mode. So essentially, it checks if we are currently in the screensaver mode, and starts and then switches out of the screensaver. So it goes in level -1, stage start timer, and then it says win. So essentially, it goes in a level that doesn't exist, which is -1, sets a timer, and says that we just won that level, so that on the next time it checks the level, it will advance it to level number 0. Otherwise, if the tilt is at 0, it will keep measuring the timeout, and if the timeout for the screensaver is smaller than the current millisecond count, it will jump into the screensaver. So this is the screensaver timeout. And then we are processing whatever stage we are in. It's like, are we in the screensaver? Are we in startup? So basically, we are starting up a game. Are we or powering on the device, essentially? That's what it is. And then, are we playing a game? And the rest is pretty much game, then dead, then win, and boss killed, and then game over. So these are the different stages that it goes through. What I did so far is I focused on the simplest thing, something that won't require any input, essentially, which is the screensaver. So I was porting only that part. So let's go to the screensaver. And this would be... And this is what I find very interesting. Most of the code here in the sketch, which is a little bit spaghetti, is having those tick implementations. So instead, those tick implementation be implemented in the classes of each of the objects. For some reason, whoever wrote that code originally decided to put just the tick functions inside the main sketch. The bosses, like let's look at the enemy, for example. So originally it was just one header file too for the classes that were implementing those. And I split them into the declaration and the implementation, as I was taught in school was the right thing to do. Yep. And then it implements only the spawn, so creating of an enemy, and then it does have tick here, which is funny, and not everything has a tick function in here. So enemy has a tick. Let's see, does the conveyor have a tick? Conveyor doesn't have a tick, but the tick, I think, is implemented in the main function. So there is some cleanup that needs to be done where we move a bunch of those tick implementations into their respective classes. So this should explain to you why my Python code looks like as it looks at the moment. So we will get to that in a minute. So the first thing I started porting is the screensaver. Yes, so Ed is making the point he has not touched the Arduino IDE for years, but he feels like it had bad support for multiple files. Yes, the Arduino IDE doesn't deserve the name of IDE. It's useful for a beginner. It's atrocious for anyone else. It's really, really bad to use. Yeah, that probably explains why this is such a one big massive file. But still, the person started moving stuff into its classes, so they did start splitting it out as it should be, even though they put declaration and implementation into header files, which is very weird. But still, they tried, and I was very opposed to using Arduino at first because my experience with the IDE is so bad. It's like the thing even takes ages to boot up because it's all written in Java and stuff like that. But I found something pretty cool, which is, let's see, this is all wrong. Let me, Arduino, the CLI. This is actually pretty cool. So this is a command line interface for Arduino. And this tool manages packages, manages boards. It can download additional board files, so you don't need to open the IDE for it. And it can build your Arduino project. So this is pretty nice. It makes the use of Arduino so much better. It's Bob the other day mentioned also that he extracted the build commands out of Arduino and put it in a makefile. Yes, sure, that is a very viable solution. But this also allows you to manage boards and download the dependencies that you need, which makes it pretty nice. It's useful to have the functions inlined. Sure, but that's but this is exactly not. So by now we have link time optimization, so it will pull in the functions into the main code and optimize it by making them inline this way. Sure, fair enough. Yeah, I didn't. That's good. It's like, don't underestimate that there might be a good reason why people do something weird. Yeah, I learned that lesson. That's a fair point. But now that we have LTO and can use LLVM to compile, or at least GCC also has LTO, we don't really need that. So I rather structure it in a way that is easier to maintain and read and contribute to than having it in a in a way which is not usually not good practice unless you have very good reasons. So yeah. Anyways, so the Arduino CLI, I used it. I'm not sure I have it set up on this computer at the moment. I would have to check, but it's not really useful at the moment anyways, because I don't have an Arduino laying around to use that with anyways. But that's how I was testing my ports or my changes to the Arduino code, is that it at least compiles. So I was using the Arduino CLI for that. So it makes it viable for me to use it if I don't have to use the UI of Arduino. And then you can also write the code in a way which makes sense. Oh, and platform I/O would be also a viable way of doing it. That's a very good point, Ed. So we could also pull the project into platform I/O, as well as well, Visual Studio Code is not bad, and I wouldn't say I'm a fan of it, but I don't hate it. I'm not sure. Oh yeah, the link that you posted is wrong because they don't own the platform.io domain. You need to go to platformio.something. It's yeah, let's look at that. Yeah, platform.io. There we go. It's platformio.org. Yeah, they didn't get the platform.io for some reason. Yeah, it's yeah. It's always a good idea to check if the domains are available before you name a project. So, just FYI. Yeah, basically, I think that's what happened. And then they were hoping to buy the domain eventually, but the person probably wanted a lot of money for it or something. They decided it's not worth it. But yeah, it's very confusing. But this is Platform.io. This is what we are talking about here. Okay, let's go back. So the screensaver tick is what I implemented so far, and I just went essentially block by block through the 4 different screensaver modes and implemented the respective effect. This is wrong. I should go on to. There we go. So I really hope this is readable. I'm trying to find a. Oh, if you have a good recommendation for a good what is it called, PyCharm theme that is good for streaming and it's not a white background, I really would appreciate it. So I will still try to improve that for a next stream so that it is a little bit more readable. Okay, anyways, so what I did so far, let's start maybe from the main function here. So main is pretty simple. I have a few globals. I made a LED string an object, so I'm hoping to essentially use that as an abstraction for whatever the hardware in the background will be, or what the interface will be in MicroPython. I have to play myself more with MicroPython to understand what the problems with it are, what the limitations are, and I'm sure I'm doing things here that will be horrible for MicroPython, and I will have to refactor them later. So keep that in mind. I know I'm probably doing things the wrong way for MicroPython in the future. Then I'm using Pygame to generate the LED string, and I'm drawing the simulator this way. So if you look at this, it just starts up. So this is a canvas from Pygame. Then we have just some screen setup, and I added a progress bar or time counter. This is for debugging purposes. I ran into the issue of using the print command for some debugging, and it was very annoying because, especially in PyCharm, the serial output or the text output is very slow, so I had to run it in the console. And if I'm using an IDE at all, then it should just run in the IDE. And I think just displaying it within the Pygame display is probably the better solution here. Anyways, so that was my decision here. And then we have the main loop, which is essentially just getting inputs or the events to open and close it. You can, not in here, if I press Q here, this should exit. And then I fill the screen with just gray, and then I do the screensaver tick. So one of the first things I want to refactor is move the screensaver into its own class to keep things together and well organized. And then the next step is to basically draw the string out. So essentially the thing that the hardware would do. So in here it would be transferring the data from the microcontroller into the frame buffer of the hardware, or sending out the pixels if we were on an Arduino. So I don't exactly know how that will work in the future yet, but that is the step. In this case, it is just drawing it onto the canvas of Pygame, and then printing the status. So this is the debug information. It basically just prints the time since we started the game, and then it commits that so that it is actually displayed and visible on Pygame canvas. Okay, so that's that. Then we have the LED string, and the LED string is just an array of colors, and these are just tuples for the colors. This is another thing that you will see in a minute. I want to change very soon to make it a little bit easier to write all the different animations. And it is using just a Pygame rect that is then being moved in the draw function. So I'm creating a rect with the right size and the margin, and it is stamping it like I'm changing the position and then setting the color, and drawing the correct LED on the string. Let me see, where am I doing this? Oh, LED, that's the color. So it is using the rect as a stamp, and then the LED is the color that is used for that rect to be drawn. Yeah, I have also an animate function. That was for very early development. I was just rotating color on the first LED. Yeah, I can show you how simple that was. Let me go back down here. And this is the tick. Yeah, there we go. No. And then welcome, fun player. Welcome to the stream. Thank you for the follow. Yeah, so essentially it is just animating the first LED and rotating it through. So it's very simple. So all I need to do is just assign a new color to the position in the array of the LED string class. So okay, so the next thing is we have the screensaver tick, which would be selected depending on the mode of the game, and all we do here is choose the mode based on the time currently since the start. So it is using every 30 seconds, it will change to the next mode. And yeah, it will be pretty obvious that a lot of the things that we are writing here originally was C or C++ code. And the way we are implementing things is very binary and very low-level type of calculations. Then we just choose the mode, and I added a little bit more comments here, which mode does what. The marching green-orange, I'm not exactly sure this works completely perfectly right, but it essentially takes the whole LED string and decreases the brightness of each of the pixel from 255 to 250. So this is the interesting thing when you look at the original code. It's using the FastLED code base, which is pretty well optimized, and it is using binary operations on bytes in a fairly efficient way to implement certain operations. So what this thing does is scaling. So a value of 255 is maximum, so it's 100%. And 250 would be the 5 is the difference between 100% and less. So I'm not calculating that in my head now. It's like, especially not on stream. I'm terrible at math in front of people. Anyways, I'm terrible at math in general, so take it. So what it does, it's just by this that's less than 1%. It's like 0.25% or whatever. It is decreasing the brightness of all the LEDs. If they are black, they stay black. But if they are lit up, then they will fade. So Tinker is asking, how long am I planning to be live? I was planning to stream for about 2 hours, as per usual. So another half an hour at least I will be here. So that's the plan. Yeah. Oh, there is also Fenderm D20. Welcome to the stream, and dark theme for the win. Okay, well, I will give the dark theme a try. We will see how that goes. I probably will have to post a bunch of pictures of different themes, and you guys can help me decide. But yeah, I will try to find something better. Thank you for that. Okie doke. So this is the operation that I was talking about might be useful to have in hardware, where you what is it? Control 10. Is that the button? Run is Shift F10. Shift F10. There we go. So you see that these are the LEDs that are being drawn, where I have my mouse. With every so long, it is drawing one LED, and the rest of the time, all the LEDs are fading. So that's how you create this fading trail effect behind the LED. It is pretty clear if you go down here and you see the time divided by 250 and then modulo 10. So every 10. And then you have every 10 quarter seconds, essentially. That's what it says. So 250 is 250 milliseconds. So time divided 250, and then modulo 10 is, and I actually probably should be using double slashes everywhere here, unless I really want it in want to use floating point math. So that's probably an improvement that I should do. And then we have the color is set by a sine. So we have time divided by 5,000, so every 5 seconds, then we convert that to radians. So we convert the degrees to radians, which is also not very exact. It's like a weird, it's 5 seconds to 360 degrees. And then, so every, what, 5 times 360, it rotates through the whole wheel or something. And then we have the sine wave, which goes up and down, then multiplied by 255, that's maximum color, and then transposed a bit. And then I had to add the modulo 256 because otherwise it was getting out of range of the color. So, yeah. You would see it when you start coding on this and you start realizing, this is weird. Because the original Arduino code uses the color wheel for the hue with values of 0 to 256 for the full arc of the hue color, of the hue value. And in the Pygame, it is using actually 360 degrees as 360 as the number. So I have to convert all this, and that's why probably this stuff is not working correctly. I would have to compare the math more accurately what they are doing in Arduino code versus what I'm doing here. But again, it's good enough for now. It just fades through colors. It's fine. And then we have the LED string loop that goes through the LED string, sets a color from HSV to RGB, so it converts the color, which is on the color wheel, with hue, saturation 255, and intensity is the last value, so 150 of 255, and that is being fed into the pixel, and only the pixels, every 10 of them, is being set with a new value. So if I modulo 10 equals n, so it is shifting through the 10 values. So you see, that's why you get every 10 LEDs, one LED is set. So the distance between one and the next LED is 10. And this is how we are getting it. So we are essentially only drawing one segment and only the last pixel in that segment, and then we are rotating through that segment. So we could just cut it off here and then start from the beginning, and then start from the beginning, start from the beginning, start from the beginning. But then we are going through all these here and then decide which one we set. So yeah, that's the first effect. I don't think I should be explaining them in such detail going now forward, but the structure is pretty similar, where we have, at first we have a fade to basically initialize the next frame. Then we draw certain pixels. In this case, we just randomly draw a pixel of a set value, of a set color onto the string. That's why it is sparkling like this. And every frame we are fading the rest. The next one is dots in ball. So let me just, I can force a certain mode to be displayed by doing this. This is not dots in ball. This is the last effect. So 2 is, I think, dots in ball. Yeah, so this one is basically just rotating the LEDs through, and they just are shifting in there as if they were sitting in a ball. And then 3 is, this one is drawing it pretty brute force, and it creating 5 LEDs around it to create a fade effect around them. And in mode 3, we have sparkle, so it randomly setting singular dots. And they are getting intense and less intense over time. So that's the third. And then we have just scrolling dots that go back and forth. 4. So yeah, there is, we can definitely add more screensavers to here and just add it to the list of colors. And if I just let it run in the background, you will see that they just switch over from one to the next every few. I can always on top. There we go. So this will not disappear now. Okay, so that would be it. That's the current status of the code base. And what I want to do, and this would be the question, what should we do next? The next thing would be to either refactor the code and actually put the screensaver in its own class. The second thing that I wanted to work on is move the change the class for the LED string to actually have a class for the for each LED, so that we have some functions for it. So currently I'm using just a top level function for the HSV to RGB, and to add RGB colors together. I think that belongs into a class where you can add pixel colors together and do operations on the pixels directly. So these might be the changes I will be doing next, as well as refactoring the code. Or we could start off adding the first elements of the game itself. I think that would be the most fun thing to do, is actually to add some functionality instead of refactoring the existing code. But I need to take a short break. Bob is asking to confront my own mortality. That's interesting. That's a good question, Bob. It will happen eventually, if that's what you're asking. But for now, I'm trying to do the best of the time that I have. I'm not sure this is the best I can do with my time, but it's fun. So I hope you guys enjoy it too. Bring some fun to the world, maybe. Yep. All right. I need a short break. I'll be right back. All right. Let's see. All right. That hopefully was quick enough. Yeah. So where were we? So I was thinking the best thing we can do is just get at least one effect running on here. We don't have much time left, but we can try. What time is it? Yeah, we have like 20 minutes. That's fine. We should just give it a shot. So where were we? I will look in the code base, and the first thing, the other basically mode that we have, besides the screensaver tick, is yeah, it's draw lives, draw attack, tick win. Yeah, let's go to the main loop. Oh yeah, this is how the levels are implemented. Basically, with each level, it's just a few calls to spawn the right thing and create the right objects. There is there are generators for those. Okay. If play. This is attacking. So this is the game mechanics implementation. Tick conveyors, tick spawners, tick boss, tick lava, tick enemies, draw player, draw attack, and draw exit. So it is, these are implemented in top level for some reason instead of in the classes that they belong into, to be honest. So there might be a very good reason for that, but yeah, the good reason was the IDE being just terrible for multiple file management. That is the reasonable explanation. So it is clearing the strip and then drawing all those different effects. So how do we do this? Probably we want to have a class for the game itself, or draw game. Yeah, if screensaver, if startup. Okay, so tick enemies. Let's look at the draw player, because we could also take the input first and create the tilts. But let's draw the player, and then probably what we want to do is take the player and move him around. That would be the best thing to do, where to start. So let's look what draw player does. And the draw player, all it does is get player position. And the player position, where is that? It's a global variable, I bet you. It's just global. Yeah, player position modifier. Oh, great. It's just a global. Okay, so let's make a class for it first. So let's create a class. Let's create a player class. Yeah, we will move them out, move the classes out of the main Python file too. It's like, I know I'm creating spaghetti myself, so I shouldn't be. Class player. Init, and then does it have any initial settings? Player position. Adjustment to player position. Curious what that is. Stage start time. Let's see how the player position is being initialized. That's a good question, actually. Play. So probably at game start, the player position is being set. Move amount. Huh. Interesting. Virtual word count. Boss alive. Move player back. Oh, so if boss alive and player position, virtual world count. And I think the virtual world is 1,000. So I know that the game itself runs on a higher resolution than the LED strip actually is. So it is being scaled from one to the other. So virtual world count. If not attacking. Welcome, Zuptor. Thank you for joining. So movement amount, so this is based on the joystick. Player direction, move amount, okay. Oh, you can switch the direction, I guess. This is bounding the speed at which the player can move. You can, oh, okay, so it is, you can switch the direction that the player is moving to plus to minus. These are all later things, we don't need that at the moment. Then it is advancing the position. And if the boss is alive and player position is greater equal virtual world count, player position is being reset to the world count. Oh, okay, so basically if you fall off the front end of the world, you are then being you can't leave. Oh, you can't leave backwards? Oh, the boss alive. Oh, the boss is the dot at the end. Is that the blue dot at the end? Is that what it is? Not sure if I understand that fully. Yeah, reached exit. If player position is greater equal world count and boss is not alive, level complete. Okay, let's look at the boss alive calculation here. Yeah, let's look at that. Boss CPP. Return alive. Lives. Now, That is, I think, still the special case at the very end, because the boss isn't... Oh, there's no boss alive. I see. This is a special case. Let's see. Because there's no spawned boss, right? Spawn is setting it to 1. Let's check where we do stuff with the boss. Gets changed on the boss level, last level. There's a level editing guide. We could read this, but I have to reread that. We don't have to read that during the stream. You can make a screenshot if you want, or just look in the code base. It's on my GitHub. Let me just post a link to the GitHub if you guys are interested to look at the come on. There we go. What are you saying? Right, yeah, so it would be good to try out different, yeah, acceleration. I was thinking, yeah, actually for the joystick controller, instead of just having a set 90 degrees off, actually do something where you tilt it and it accelerates. But I was also thinking what would be cool is if you double tap, you can accelerate faster. You can basically just force this thing to be faster, or accelerate faster or accelerate slower, depending on how much you do the clicks, because you can really whack this thing pretty well. And that might be interesting to make it a little bit more vigorous, the gameplay on this. So things to keep in mind, yeah. It's not a bad idea, Ed. Let's see. I'm still looking for that boss stuff. Where is it being set? Spawn boss, yeah. Spawn boss. And there's another implement, yeah. Spawn boss and boss spawn. Last level true. Move boss. Spawn enemy. But what is the init value of this? Am I just stupid? Yeah, there's no initializer for this class. Yeah, where is the class being initialized? Yeah, where is it being created? Oh, there's no news. Correct. No news, because we don't want to do any stupid memory management on the heap, which makes sense. You don't want to do that on a microcontroller. So we have the pool of the enemies, the pool of the particles, the pool of the more particles. Oh, it depends on which Arduino we are running on, how many particles we have. This game got ported to a smaller Arduino, so that's why. How many spawners we have. So that's why you have factories for this. And yeah, so boss. Okay. Boss. Yeah, boss killed. Spawn boss, move boss. Level complete. Last level, stage boss killed. Okay, but that's not what we are doing. Tick boss. Boss alive. I still don't understand when how the alive is being initialized. Draw exit. If not boss alive. Again, where is this initialized? Because there is no initializer here, is there? Oh, wait. No. Yeah. Yeah, there's no boss here, right? I'm not blind or anything. Take boss killed. Take die. Game over. Special effects. Yeah. I don't see a spot where the boss alive, not alive is being initialized. I don't know how that happens. Is it just assuming that the memory will be at 0 or something when the Arduino starts? Oh, you found it? Line 22? That's the wrong thing. I did the wrong thing. There you go. Sorry about the chat there in the stream. Yeah, that's the spawn. That is correct. But the spawn doesn't happen in every level. You have to go on the into the right. Yes. There is a branch for it. The cleanup branch. I should just merge it into master because no one will be pulling my things anyways. I did submit my branch to the guy who I cloned it from to GYP, but I have the feeling he will not find the time to merge my changes. And I might be doing things that don't make sense too. There we go. So there we go. So the point is that this CPP implementation, so here spawn is only being called when we are in the boss level, right? So level number -1, and I don't see stage win. Oh, right. So I think it is wrapping around. So it is basically indicating as if we just finished the last level. So win would be tick win. There we go. Tick win. And tick win will do this. And then next level, call next level. What is next level? Does it set the mode? No. I can probably hover over it. Level number plus plus. If last level, level number 0. Oh, if it is last level, then it says, then it wraps around, okay. User settings, lives per level, yeah, it is setting it to 3 again, then loads the next level. Fast LED, set brightness, update lives, clean up level, player alive. Player position. Oh, player position is being set here. There we go. Set LED brightness, update lives. Cleanup level. I have the feeling it's cleanup level. Let's look at cleanup level. Boss kill. There we go. Okay, there we go. So the boss, so this is what is doing all the killing of all the entities. That's what it is doing. And then, so the cleanup level is cleaning everything up. Update lives, I assume, is doing, writing this, yeah. Use live LEDs, this is a setting, and then draw lives if it needs to be drawn. Okay, we don't need to work on that at the moment. Okay, and then when we scroll down, the load level, depending on which level is set. There we go. Just realized this is, let's move on. Sorry about that. There we go. Okay, so this sets by level number, and then it spawns the enemies, which spawning will set them as alive. So if we look at enemy, a spawn essentially sets it to alive as 1, which was reset just before that. And then if we are in the last level, that's the spawn boss thing, and this will set it to 1 again. There you go. So basically, I had the feeling as if this was being checked before, but the reality is that the state machine goes not attacking. It doesn't get into the play mode. It first gets into the win mode. So this is, if we are going out of the screensaver into the normal mode, we essentially win level -1, which causes us to go through the whole commotion of ticking win, which then will eventually reset all the entities, spawn the correct entities for level 1, and also set the boss, and that as part of that, it will set the boss to be killed. Wow, okay, so that's how this works. Okay. Yeah, I'm not sure how I want to structure this, because this feels like it will work, but I feel like I would have to start with the state machine first and go through the stages before I can actually create the entities. I'm not sure what this emoji is here. Spaghetti. Oh yeah. Okay. Yes, it's spaghetti for sure. Yeah, it goes through like all this, going to a non-existing level -1, then going through winning of that level, then doing all this stuff it would do if it was starting the next level, including resetting and loading all the entities as necessary. So yeah, that's the magic here. Okay, so what do we do? All we want to do is to be able to draw a player. And I feel like if we are, this is going into startup, and startup mode is what? Startup is taking level number 0 and then loading a level, which will also reset the entities. Yeah, the question would be here, do we need to do that? Oh, for sure now when we are running on the computer, we definitely don't need to have a pool of objects that is pre-allocated. I don't know how MicroPython does that anyways. So at the moment, let's do it the normal way you would do it on a PC, and if we need to change it, we will change it. So let's create a player object which doesn't exist here, and combine the variables that are necessary for a player. And the player has player position modifier. What is that? Okay, player position, and it doesn't require me to set that at startup, I think, when I'm creating the object. Just position, right? Wow. Oh, the machine is slow. Let's close this. I think it's the having Python, the game running in the background, it's somehow leaking memory like crazy, the feeling. So let's have position 0 as one of the parameters. And then move amount. Probably the moving stuff should be also part of the player. Yeah, move amount. Yeah, we can have parameters for it, which is play direction, not player, just direction. Just one is the default, right? And then move amount should be, yeah, I have to look up what this player position modifier thing is meant to do. Why is it complaining? So let's do this. Now, dev draw. Yeah, let's just do that. Because they are using the language tick here for everything that would be advancing the position or anything. So yeah, draw player would be just draw it at the position. It doesn't need to advance anything. We could put the game logic of the player inside the player, right? So all these weird things, but then we have to pass a bunch of different variables. Whatever, doesn't matter. Let's just do draw and then do the operations on the player in the game code for now. And we need to pass it also the let string. And then we just draw color. Oh yeah, this is also a set thing somewhere. Draw player. I should keep an eye on this. There we go. Come on. Do a poppy-uppy. There we go. Draw player, just green, correct. Let string, and then self position, and that equals. This is something I will have to refactor. There we go. And what else? We can also do the, let's do move. Speed. Yeah, we should just have speed here. That's the modifier. And then we can have if direction is 1, then no, if direction is -1, yeah, well, then we can just multiply it. So yeah, the amount is a speed times direction. And we set position, but it also should know about the size of the LED string, right? So it should be bound. Yes. And now we can bound it by plus and minus so that it won't get out of this. If no, kleiner, smaller than 0, then position equals 0, so we will just bound it, else position is larger equal len let string. Then we will set it to let string -1, correct? Yes. There we go. So this way we can control the position, And then what we can do is just all we need to do is basically reset the LED string. Screensaver, let's just disable the screensaver. We need the gameplay Pygame stuff, TWANG globals, and then player is just player. And do we need anything else? No. We just need to reset the LED string. LED string should have a function to be basically wiped. Let's do this way. Clear. Yeah, we need a clear function here. Yeah, I can't do that. I don't remember. Yeah, for E in range len screen. No, what was this? Self-leds. No, what are you doing? Self-leds E equals, and then reset it to black. 0, 0. There we go. So that would be the clear. Now let's go back. Led string clear and player dot draw led string. Correct? That should do it. Let's try that. Invalid syntax elif, and I forgot a colon somewhere. Let's go there. Yep. Bam, explode. What did I do this time wrong? Player doesn't have an attribute position. I did add that. Position, player position. Yeah, I did create this. What am I doing wrong here? Oh, self-position. Ah, that's so stupid. Okay. Yes. I know. I'm really dumb. Yeah, that's you see how good I'm at Python. So sorry about that. Stop screaming at the monitor, please. Let's string. Do I need to put any more selves in there? Direction, no. Position, amount, direction has to be also. Dot. This is so this is not the whole self reference related stuff in Python is not very natural to me, so sorry about that. Okay, let's try it now. Yeah, there is a green dot. Perfect. Yeah, Ed, it's, yeah, the self being implicit is fairly nice, but I can understand why they did it this way, because then you have local variables there. Then, yeah, I don't know, but you have scope search. It's like you have scopes for this, right? You are in a class scope. Anyways, whatever. But then you would have to declare them, and Python is not declarative. So yeah, that does make sense. Oh, and then I forgot this too. I should do that. Self dot. That's why they are gray, because thank you, syntax highlighting. Okay, so let's do just let's just make the player move. Just speed is 1, so it will move with 1 frame per second to the right. Blonk, explode. Let string not defined. Oh. What? Where? Oh. Right. Speed, and then I have to keep the let string. Should it retain, when I'm initializing it, the LED string so that it has the information about the playing field? Playing field. Playfield probably should be its own class. Yeah. And then, because the playfield has to be bigger, so if we are implementing it the same way as the original, then we would have a playfield, which is bigger, which has like 1,000. And then we are shrinking it down or onto the actual LEDs. Do we want to open that can of worms yet? Maybe not yet. But we definitely want to add let string here for now. It can retain that information. I don't think we direction. Okay, and then we don't need to do that because we can just access it from past memory. Self dot, and then we can access it here too. Okay, and then let's see. Let's go back. Right, when I'm creating it, I should create the player and pass led string to here. And let string. We don't need this. And then let's do that. Yep. And it will get stuck. Yes. No, it crashed. Great. List assignment out of range. It shouldn't do that. I did try to bound it. Yeah. Draw self, position, move. It's bigger, equal. Oh, yeah, -1. There we go. Now it's correct. Bam. Okay, perfect. It's getting stuck there. So now we can we could just add a semi-joysticky thing by just adding an additional key here and make a variable. Yeah, this is just temporary so that we can move it around. This has to be implemented better. Running, and then yeah, let's add it to here. Oh, we should just call it in here for now. Should just do this. Oh, come on. It's a little bit slow in here. There we go. elif event dot key equals pygame k underscore left. Let's do left. Let's try it, and then player dot move -1, and then elif event dot key pygame, because we could actually, what we should do is on key down set a variable that moves it around, and then on key up we should disable it, but for now we will just do it on every key down. Okay, right, and player dot move 1 up 1. And let's do this. Let's try it. Da-da-da! I can move the player. Very nice. Okay. Let's do it better. Let's do this as I said, and do player move there. Should be by default, it should be 0. Then key down should be, no. Player speed, and then player speed to the left should be player speed equals -1. Yeah, we could. So what I will do essentially is add this to the class so that the class actually has a local variable that is the player speed, obviously, and then Yeah, but for now it's good enough. So that we can do more of the, then I have to convert the draw into a tick, because then it is actually, each action is all moving the character and drawing it. So I think that will be better. Event type, pygame dot key up, if event dot key pygame dot k left or k right. So yeah, we can do it, or do I have to do backslashes there? Let's just do it in one line for now. Event dot key equals pygame dot k right. Yep. Player underscore speed equals 0. Now let's do this. All right. It's moving. We have the player moving. It's fantastic. Fantastic. Oh man, that's awesome. Okay, that's fun. So we did something today. We added a player that we can move around. Isn't that cool? Yeah, I don't know if I'm a huge fan of the controls yet, but it's a good beginning. It's a good beginning. Very nice. Okay. So we did something. Yeah, we are half an hour over, but we implemented something. That's useful. Now I have to commit all that. Let's do the commit part, and then we will be wrapping up. Okay, TWANG. It's fun. I like it's writing Python is definitely a lot of fun, I have to say. Yeah, in PyCharm also having an IDE that does the completion. I think it would be also great in Sublime Text by adding a few plugins and stuff. But it's like PyCharm seems to be doing the job. But the problem is I feel like it is slowing down the longer the stream is running. It's like when I have all this encoding running in the background, it's not great. So maybe it's not a perfect solution. Maybe I should put more effort into getting Sublime Text to do the right thing. Not sure yet what I should do, but okay. Let's do git diff, and we added clear to the string, we added a player, we disabled screensaver, and added movement of the player. So it is pretty simple. Let's also look at the README. Oh, that's the wrong Sublime Text, I think. Oh, too much LEDs. Come on. I managed to switch on a LED animation on my keyboard. Very good. Where was I? Yes, so PyCharm, let's open the README. We want to, yeah, we implemented a player. Let's mark that off. It's stretching it a little bit, but it's a beginning of the player. So let's mark that off the to-do list. So in the README, you see I have a checklist for what I'm working on. So we have a player and we have controls. Yeah, it's like maybe a little bit. Yeah, let's not get ahead of ourselves here. So I will not mark that off, but I will mark off player implementation. We will move that in its own files in Python. Don't worry about it. It will be structured properly. But for now, let's do some spaghetti coding and get from the spaghetti to cleaner code over time. Diff. Great, great, great. Very good. Nice, nice, nice. Added player class. The player can now be created and moved around. Very nice. Exit. Push. Let's push it. And here you go. So, if you want to see my wonderful code, you can find it on my GitHub, Esden, TWANG. Yes, there we go. You can find it here. I will post it in the chat just in case. But otherwise, that would be it. So yeah, that's pretty much it for today. There we go. So thank you for joining. I will continue working on this. I still don't have a schedule, but I probably should set it up fairly soon. I should try definitely. So last week I didn't manage to stream during the week at all. I will definitely try to stream during the week at least once, and not just on weekends, because I know that it's more convenient for some people. They are too busy to watch streams during the weekend, which is interesting. But yeah, I will try to set up something during the week. I will probably do some more coding on this code base, refactor a few things. I will let you know what I did in the next stream, so you will get an update. We still need to do the survey if we should go with Arduino or with MicroPython. Although I feel like I want MicroPython more than Arduino, but yeah. Otherwise, and thank you for the Patreons. Thank you so much for supporting this. This kind of streams are definitely very encouraged by the donations there. If you are interested in the Icebreaker, check out the 1-Bit-Squared store. Everything is so yeah, the Icebreaker FPGA, which we will be using as the platform for this game. Check that out. It's on Crowd Supply as well as on the 1-Bit-Squared story, which you should find links underneath. I should do one more thing that I definitely I should log in here. Just give me a second. I should give a shout out to the Patreons that are donating $5 or more. That is their perk, so let's not forget that. Just a second. I should make a list again on a post-it, just like I did before. If it loads. Yeah, this computer has too many open things. Where are we? Come on, load. I have to manage the amount of browser windows I have open better. I don't even know where to find this at the moment. Oh, God. There we go. Update. There we go. Awesome. So yeah, so the big shout out to Garrett Kelly, James Neal, Jay-Z Hacker, Jordi Parky Rodriguez, Kate Temkin, Robert Miller, and Sid Price for supporting this. It's like this is thanks to them. These streams exist, and if you want to support what I'm doing here, then definitely check it out. Yeah, I'm seeing you hopefully soon on a next stream. We will keep working on either this game or working on something different. We will see. But for now, if you have been, thank you for watching. Have a good one. Bye.